Good evening, sir.
Yeah, good evening, sir. How are you doing?
I'm fine, thank you, sir.
Okay, that's good. Where are your brothers? No sisters. Brothers, but where are they?
Trying to wish them.
Don't call them.
Contacting them.
Don't call anybody. Don't call anybody. It's not necessary.
Okay, sir.
Yes. You all have to be serious. So I'm going to start. Whoever joins,
Okay, sir.
come on, yeah. Okay, so let me record. I hope I'm recording. Let me check. I'm recording. Yeah, I'm recording. Yeah.
Okay, sir.
So 3D analysis. 3D analysis.
Yes, sir.
Yeah. So 3D, I think we have to appreciate 3D because there's 2D. And so if you have 2D,
Yeah.
then what is 3D? Okay. 3D, to look at things in 2 dimensions, look at them planimetrically. So we are looking at it from the top. All right. So
Okay,
when
sir.
we look at things not only from the top, but we consider the elevation as well, then we are dealing with what? 3D. Are you okay?
Yes,
so 3D analysis is very important, and we have to talk more about it than just this one. I think we'll talk about surface analysis. So, but for now, let's look at 3D analysis and then viewshed analysis. We want to just look at a few things. We'll revisit this topic again. While you are looking on the board, while you are looking on the screen, not the board, you know, is what we call a viewshed. Okay. So,
yes, sir.
Can you imagine that this is some sort of terrain? Okay, a surface, maybe somewhere in the world, I don't know where, maybe Iraq, maybe, I don't know, Ghana, I don't know, anywhere. And you wanted to know areas that are visible. You wanted someone to show you which areas are visible from a certain viewpoint. Okay.
Yes, sir.
So the yellow areas are the areas that you see from particular, viewpoints. So we could have there are several possibilities. Okay. So instead of having these, areas, these yellow areas shaded, You could also have, you know, other, if you stood somewhere else. Okay, so let me just put a question mark. Okay, the question mark is not good enough. Let's try star. Okay, if I stood where the star is, maybe this is my view shed. Okay, and then
Yes, sir.
I can also decide that, okay, if I stand up here, what will my view shed be? In that case, it won't be what you are looking at on the board at all, because the view shed represents the areas that are visible from a particular, you know, point of view. Okay, simple as that. And so we just want to put that in our mind, take note of that. Excuse me, I got a little code, but bear with me. In this area, code, there's a lot of code everywhere. So a view shed is an area that is visible from a specific location. A view shed
Okay.
area that is visible from a specific location. So your view shed, wherever you are right now, you should be able to see what I'm talking about. It's very practical. Where you are sitting right now, if you look around, the areas that you can see, those are your view sheds, and it's not everywhere that you can see. Okay, all right.
Yes, sir.
So now the trick to view shed analysis is to actually use a raster data, you know, as the surface, as a representation of the surface. All right.
Yes.
So let me move this one aside. I'll come to that diagram very soon. But the view shed considers that, okay, if you have a set of cells defining the raster, okay. No, I think this is not the best of drawings. Let me undo. Let me be a better one. Yes. I need to move this out of the way. Well, let me just clean everything. Okay, so let me just wipe. Okay, so if I have raster data as a picture, I mean, raster is just a picture. You should always have that in mind.
Yes.
Pick a set of pixels. So if I have a set of pixels representing my surface, okay, the trick to view shed analysis is that I have a point, say this cell becomes the observer's location. Is that okay? But then
Yes, sir.
the cell, that cell has a value. Say, let's give it 1. Okay, let's see the value of 1. Or let's say 2. Let's call this 9. Let's call this 1. Let's call this 4. Let's call it. So because every raster or picture contains values. So 3, let's call this 5. Okay. Let's call this 0. Let's call this 1. Let's call this 3. Okay, so what am I actually doing? What I'm trying to do is that I'm trying to figure out the value where I am, value of the cell in which I'm standing. And then I'm trying to see which cells are visible from where I am.
Your point of view.
Exactly. So if I'm at this cell, so let's try to give some numbers to it. So 1, 2, 3, 4, 5. So this column 1, 2, 3, 4, 5. Column 1, row 1, 2, 3, 4, 5, 6. So the question is, which cells are visible from cell number row 2, column 1? That is how viewshed works. Okay, so if you can answer that question, you understand. It means you understand how viewshed works. So the
Yes.
observer's location is
2.
2, 1. Okay, if you go by
Yes.
row column convention used in matrices, then 2, 1. What are the cells that are visible from that? cell. So can we mention a few cell numbers that are visible?
3.
No. So those are values. The location of each cell is defined by the row and column numbers. That's raster. Basic definition of raster model. Excuse me. So,
Okay, sir.
so what you are calling 3 is actually 1, 1, 1.
1, 1.
Yes.
So that's
So give me another one that's visible from cell number 2, 1. And why is 1 visible?
cell number 2, 1.
Why is 1, 1 visible? Why is this cell visible? Why is this cell visible?
1, 1.
Why is it visible? Please listen and then give an answer. Listen first. Why is the cell number 1, 1 visible from cell number 2, 1? Okay, so you just said it without understanding what you were doing. Okay, so it's assumed that this is a surface. So every surface is defined by values. Are you okay? So when you look at a terrain, a normal surface a ground, yeah, the topography, somewhere you are walking on a ground. In that case, then these values are what? If you are walking on this surface, what are the values?
That's 3, 5,
No.
9.
What
4, 1.
do the values represent? What are they? Listen, the question is, what are they? Who are you? It's different from what am I seeing? Are you okay? What really is that?
That's the terrain. The terrain.
What are the value? What do the values represent? This is where, if you get it right, I'll just take it that you understand and I'll move on. But if you're not getting it right, it means that you don't understand what I'm talking about. It means I'm just talking for nothing. But if you immediately get the answer to this, that's it. It means you get it. Because there's another thing called watershed, and it also uses the same principle. If this is a surface that I'm working on, what are the values there?
The values
An interesting one, isn't it?
Show the terrain.
The values.
I think it's tricky.
That was my answer.
What is the answer?
So
it's what?
The values show the terrain visible from the observer's view.
No, at the moment, we are saying that if the observer is at row and column 2, 1, okay?
Yes.
Which cells are visible? And you were able to tell me some cells that are visible, but you didn't know why you chose those cells. First, you said it's this one here. Yeah?
Yes.
And I said,
yes,
fine.
Sir.
I didn't disagree with you. I assume you knew what you were doing, but you didn't know what you were doing. What is that value? What makes it visible? Okay, let me add more values to it. Is the value I just put in, is it visible?
No, sir.
Why is it not visible? The answer is
from
correct.
the observer's view.
Say again.
From the observer's view. From where the observer is.
The
value there is not visible
because
9
is blocking it.
9 is actually blocking.
Yes.
The observer from
that
seeing
is it.
two.
That is exactly it. So what it means is that when it comes to viewshed, your height is very important. In other words, if someone is taller than you and they stand in front of you, you can't see. Is that not so?
Yes, sir.
But that is what we are actually talking about here. So viewshed is something that is, we're dealing with height, elevation values. Okay, so this particular raster layer we are looking at, these squares that I've drawn, okay, these are all, these represent what we call the so-called DEM. It's a digital elevation model. Okay, so this is a DEM.
Okay, sir.
Okay.
Yes, sir.
So it's a picture, but it's not your normal picture. It's not your selfie. This is not a normal selfie that you take. This is another type of, picture in which the values in the picture represent elevation or height. Okay. Is it clear?
Yes, sir.
Any question on it? So what does a computer does? You give it this value and you tell it that, okay, I want to be standing here. I want to be here. I want to be here. Tell me which areas are visible. So you can supply a couple of points and it will tell you that, okay, all these areas are visible. Are you okay? All these cells are visible.
Yeah.
That kind of thing.
Yes, sir.
Are you okay? Now, what does it mean for security?
Yes, sir.
Security application. What's the security application for this?
The security application.
Yes, if I can tell areas that are visible from certain points, what is a security application?
The security application is, I think you're on a higher ground.
No, so tell me practically. Use the president as an example. The president is traveling. Security for him. What does this mean? This is how practical it is. It doesn't get any complicated. So Cyril, come again. Yes, it possibly means that the areas that are marked are higher grounds. Yes, but what does it mean for the president? Yes. In terms of security.
Hello.
Hey, you people, you don't know anything. What does it mean if your president is visible, if your president is traveling and he's going to be within this area? What does it mean? It means you need to place a military, snipers or something. You need to get some personnel here. You forgot. You got it. Do you get it now?
Yes, sir.
Do you get it? Okay.
No, sir. No, sir. I don't get it.
You don't get it. Okay. So look at it again. The Viewshed tells us areas that are visible from a particular point. Are you okay? Or particular points.
Yes, sir.
All right, great. So we've determined that a point like 2 won't be visible. All right. Okay, since 2 won't be visible, that means I can hide there, right? If I'm there, nobody can see me. If someone has a gun and they shoot, they won't get me, right? Anybody who is standing at 2 won't get me. So that's where the security stuff come in. So what we can do is that with the Viewshed analysis, we can shade so many squares that are, say, visible or not visible. In this case, let's say, assume these are visible areas. Are you okay? So I was saying that if we are looking at the security application of this, and the president was traveling and it was going through this area, then it means that the president's security attaché or whoever is responsible for his security should be able to obtain, this kind of Viewshed, do this Viewshed analysis, and tell that if he stays here for 5 minutes, are you with me? He's exposing himself to a certain danger, but then you know exactly where the weak points are, and the weak points are the yellow marks. Which are the areas where he'll be standing? The areas that are visible from where he can be seen when he's in the blue area, the blue region.
3516.
Okay, I want someone to contribute to what I'm saying. Whoever understands, contribute to what I'm saying to help all of us understand it better. AB, do you get it somehow?
Yes, sir.
You get it somehow. So your data source is a DEM, which is actually a raster. Are you okay? A raster data set. It's a picture. But in that picture, every square in that picture, remember, if you take a picture right now of yourself, the picture is made up of squares. We blend that in GIS. Okay, yeah. Great. So now if I decide that that picture I'm getting from my neighborhood, Medina, where I am, is a picture that shows just values, okay, height values, elevation values. Then what I'm holding in my hand is what we call a digital elevation model. The use of the digital elevation model is to be able to generate a view shed by supplying points which are actually the observer's location. Are you okay? So we can use this to help us plan in terms of security. At the same time, someone who has a bad intention can also use this to plan. Are you okay? You can also decide, okay, this is where I need to be in order to get him. You get it? So there are two sides of everything. The knife that cuts tomato is the same knife that people use to kill. Are you okay? So we need to look at both sides. But then I want you to understand how the values are being used and the pixel values. Are you okay? And the area, the view shed area. So before you join in, I was showing Cyril this PDF. Okay, this one shows you the yellow areas are areas that are visible, okay, from a particular point. So let's say it could be from, I can't see this one. Let me get a better marker. So I was using this star. It could be that when I'm at this star, this is what I can see. And I was telling him that it also means that if I'm at a different place, I'll be seeing something else. Because now in fact, this is also called the line of sight analysis. The Viewshed analysis is also called line of sight analysis. Are we on the same page?
Yes, sir.
Yes, sir.
You see that the coloration, the yellow areas now represent what I'm showing you on the other side. Okay, so the yellow areas are these areas that you are seeing here. This area. Are you okay?
Yeah, yes, sir.
But this is actually to explain the theory and the concept. And the other side, you see the actual thing, like the image itself. Are you with me?
Yes, sir.
All right. Okay, so any question on this one? Otherwise, I think that is basically it for Viewshed analysis. You use a DEM. You see, I've just talked about that. Okay, and application goes beyond security. You can look at telecommunication towers. So who can explain to us how telecom towers, the amount, where we locate them, how does it relate to Viewshed analysis? Anybody?
I think it's been mounted on higher grounds so that it would have a wider coverage of
okay, so in this case,
of,
okay, I get it. You need to go higher. I think Cyril's answer tonight is he only has just one answer to every question. All his answers are go higher. Okay, and I think please sometimes you need to come higher in your answer to it. Are you okay? So
yes, sir.
the idea is that every telecommunication must, not all of them, but most of them transmit signal. Okay, others also reflect the signal, repeat the signal, etc. So for to be able to know which customers are receiving your signal, you can do a Viewshed analysis and see where the signals will reach. That means that we need to know for every transmitter the longest distance, for the signal to go. Are you okay? That the signal can go. And then we need to also know the shortest distance that the signal can go. Is that not so?
Yes, sir.
All right. So yes, you are right. It means you need to mount it higher. I mean, sometimes when you think about it, everything will come down to mount higher. Are you okay? In fact, yeah, that is what it's going to be. So Cyril, I think, yeah, you're giving us, an answer to, we don't even need to talk about it. Just mount it higher. You'll be okay. Okay. But the reason you are doing this is because already you probably have some telecommunication, some towers already mounted, already out there, and you want to expand so that you can reach some customers. Is that okay? So in that case, if you don't do this analysis, you'll be making a mistake. You probably put it at some place which is not optimal. Are you okay? Another word for optimal is what? Another word for optimal is best. Are you okay? So you want the best location for your mast. You just don't want to mount it somewhere. Are you okay? Right. So that you go and mount it, then you get another call. Please, you are not getting signal here. Can you then you come and you go and mount another one? You know how much it costs to go and mount a mast. So now this brings extra cost to the company. Are you okay? So, but then by doing an analysis like this, then you know that okay, we are planting a way we wouldn't have to worry again about these people. All right. But then if they left you alone to go and mount the mask, you'll be just looking with your eye. Okay, why don't you put on that mountain? Okay, and you can't get it right. Because let's not forget that at the end of the day, all these are implemented in what? Software. Okay, great. So we need to consider a few parameters. We need to see the angle at which we are actually looking at. The observer, if the observer decides to look down, okay, or to look up, it will expand his view. Do you also agree to that? See, so
yes, sir.
Yes, the observer's view can change. So we need to consider things like the vertical angle, the horizontal. Can the observer turn their head? Okay, how far can they go?
Yeah.
So that will be horizontal angle. Are you okay? Then the vertical, how high can they go? And you see, if they take their head out, then they can see further. So that spreads the view shed. Are you okay? And expands it.
Yes, sir.
Are you on the same page? Okay.
Yes, sir.
All right. So many cells become available. All right. So take this statement, for example, cells of higher value are between the viewpoint and the target cells. The line of sight is blocked, are you okay, and cannot be part of the view shed. Once you have a cell that is blocking another cell, because the value is higher, are you okay, then the cells behind it cannot be seen. Okay, this is what we just talked about. All right, so we can limit the angle that you can look at. So just for example, if you watch there's a movie that I watched, the one with, is it Kevin Hart, this funny American comedian, Jumanji. Who has watched Jumanji?
So I have.
You have. Okay, Jumanji. You remember when the guy that turned into a girl in the game?
Yes.
And then she was dancing. She had this gift, to kill. The dance fighter or something like that. Remember that, right? Okay, now the security guys that she went to beat up down the slope, you realize that in order to bypass a security personnel, then you need to look at how they are turning. In Prison Break 2, we have the same thing happening, isn't it?
No, sir, you're fine.
To be able to escape, then you need to know the view angle. Are
We
you
are
okay?
class zoom.
All right. So
Yes,
in
sir.
any analysis, if it's a security application, you need to look at whether the person, a human being, how often do they turn? Are you okay? Then you know their view shed. Are you with me? That's for security.
Yes, sir.
And then for the telecommunication mast, the mast is not a transmitter. The transmitter is actually some gadget that is mounted on top of it. The mast itself is just a structure, a supporting structure. Are you okay? So you need to look at where it's pointing, and then the manufacturer should tell you the signal can travel 2 kilometers. Now that will define how far you go with your view shed. So going back to the board, the diagram I want to show you. Where did it go? Okay, this one. So when you look at this one, this is actually these are parameters that we can actually set. For example, we need to recognize that we can have an offset from the ground. So the height of the mast will be the offset. Are you okay? And then the targets, okay, where the signals are going. Okay, we need to also consider the height of that. So that will be offset 2. Okay, then we can look at, of course, the angle, vertical angle, horizontal angle. A few parameters can be put in. So for any software, for example, R2 will be the longest distance, the farthest reach of the signal. Okay. If it's a view shed, if you are looking at how far a human being can see, do you know we can tell that at a certain distance you can see? Do you agree?
Yes.
Okay, so that will be R2. So we need to put that if a human being is standing here at this point, then we need to be able to, you know, put in how far they can see. Every human being cannot see beyond a certain distance. That will become out. We put that into the software. Are you okay? And then we're able to now delineate, shade the areas that are possible to see. Okay. Someone is writing on my screen. Ernest is always writing on my screen. Ernest, are you okay? All right. So the offset is there, the vertical angle. So when you see V1, that's vertical angle. Azimuth, we all know azimuth will tell us how far we are going in that direction horizontally. Are you okay? And yeah. So R1, R2. Sometimes you can be very close to a mast, but you can't get this signal. Are you aware of that?
Yes, sir.
Your house is right, you know, under the mast, but you are not getting the signal. Okay, so that's R1. That's the explanation for R1. That when you are, sometimes you can't see so close to you. Are you with me? Yeah.
Yes, sir.
All right. Please, any question on Viewshed? Because I think I've said enough on it. Any questions on it? I'm moving on. I'm changing subjects. Okay. Do you understand this statement here? 90 degrees looking straight up. Minus 90 degrees looking straight down. Who understands this? Excuse me. What does this mean? A vertical angle of 90 degrees, positive 90 degrees means looking straight up. Minus 90 degrees means looking straight down. I hope you appreciate what that means, right?
Yes, sir.
Yeah. So download my app on Play Store. You understand this, how this one is done? Yeah.
Which app, sir?
It's called the Height Measure app. I'm advertising during the lecture. It's not ethically right. Okay, so let's see me later.
Okay, sir.
So if you're looking straight up, are you okay? That's like 0. Are you okay? Look straight down, minus 90 degrees. When you look straight up, the 90 degrees is this angle here. Are you okay?
Yes, sir.
I hope you appreciate what I'm saying. So it means here we are looking straight on top. Here we are looking straight down.
Yeah.
We're looking straight up. Are you on the same page? For the viewer, are you okay? The viewer's eye is here. So instead of having the viewer's eye, for a security application, is the human eye. For the telecommunication mast is what? Is the transmitter, not the mast.
The transmitter.
Transmitter. Because the transmitter itself is like this, some gigantic something that's mounted on the ground. Is that not so? But then we can have, you heard of co-location. Didn't you hear about co-location?
No, sir.
NDC, when NDC was in power, you know, and you were talking about, I remember very well when they were in power before MPP came, they were looking at that so that it's not like this mast is for MTN only or Vodafone. Are you with me? But then Glow can also go and mount it. And later on, there was this political thing that people were talking about that they didn't want Glow to come into the market. So they were actually sabotaging them and say that they won't let them, you know, put their transmitters on their mast. Oh, you didn't hear about this? Okay.
That's when they put it under the ground.
And you also remember, have you also seen the new mast in town? Have you seen those coconut trees that they are putting transmitters on? Anybody has seen that?
Oh yeah, yeah.
It's like a coconut tree or something. In fact, the first time I saw it, it was scary. I was like, what is that?
10 years ago.
They started it a long time. It's been there for a long time. Hey, I don't live in
The one
Ghana.
in Osu.
I don't live in Ghana.
Has been there for a very long time.
Oh, okay. Then I've not been living in Ghana. So yeah, you can see that
Just
anybody whose building is here won't be able to see. Won't get signal. See, he's so close. Are you okay? And so now the R1, which is the radius, the shortest radius, all right, should be factored in so that we know that someone like this, he won't be seen. So the fact that you are the next cell doesn't mean that you are visible. Are you okay? We need to consider the parameters. we need to consider the vertical, the azimuth, the radius 1, radius 2, okay, offset 1, offset 2. So offset 1 is what Cyril is talking about. He says he doesn't, I don't think Cyril is only saying mount it higher. He's also saying that make the mast very high. So let's laugh at you a bit. Is that okay? So yeah, I mean, basically, it's like take it high. The higher you take it, you don't have to calculate anything. Are you okay? Everybody will get a signal. But you see, it's not optimal. It's not cost effective. Okay, we're moving on. I'm sure if ever you get a question on this, you understand, you'll be able to answer it. Okay, let's talk about another topic. I want to draw your attention to 3D visualization. Is that okay? We'll talk about GIS. GIS is not only dealing with 2D, because most of the time we talk about GIS, you have the map view, isn't it? And then you are doing your layers. And you are doing the, all sort of things, and buffering and all these things, and then your parcel of land. But you can actually do a 3D, rendition of your data if you have the data. If you have it, then you could. So what you are seeing here is like visualizing on the top right. You are kind of visualizing, let me say average income or something like that per household, and then you are extruding the property. You are extruding means you are kind of stretching it. Okay, now it's easy to make a presentation with this one than to just do a 2D presentation of average income, just say, okay, per household. That doesn't make sense a little bit, right? Now you can see that we've overlaid the 3D extrusions on a map, okay, some kind of satellite imagery, and this makes better presentation. All right, now down here you can see these are drill holes in the mining area. They are dealing with the ore, the gold ore, the ore that you're going to take before they go and extract the gold. So you can't show them 2D. 2D means you want to steal the gold. Are you okay? So you can see that here we are making every effort to show you in 3 dimensions. All the lines going up and down are lines that are created by a rig. Are you okay? A drill. Have you seen a drill machine before? It's a huge machine.
Yes,
and they take it on, they put it on some kind of articulator, and it's very huge. You don't, seriously. And they go drilling in there and get to know the 3-dimensional, how big the resource is, how large the resource, and the resource is the gold. If you hear the word resource, it's not resource, it's gold. Okay, they're taking your gold away. So now we need to appreciate 3D when it comes to things like gold. Okay, as a all. All right. So basically, I think you see the same thing here. I prefer to have a 3D rendition, okay, or 3D visualization of a phenomenon than to look at it in 2 dimensions. Okay, so 3D analysis should not only look at analyzing it in 3D, but we should also visualize it in 3D, because what we just did in Viewshed is 3D. Do you agree that it's 3D? But then we're not visualizing in what? In 3D. Anytime you do spot heights and you're actually trying to represent a 3-dimensional something, but then you are not visualizing it in 3 dimensions. Just like watching cartoons in the 1985s, 1980s. Are you okay? See the cartoon flat,
yes, sir.
as opposed to the cartoon that we are looking at today. Okay. Sometimes you are watching cartoon on TV and you are wondering, are they human beings? Because now they are kissing and all that too. Are you aware? The cartoons we have these days, if you are not careful, your child is watching.
That one, Cyril, there you talk.
Eh?
Cyril,
All right.
talk.
What did you say? I didn't hear you. You said?
I said Cyril. That's what that one, he knows about the kissing.
Cyril is very good at that. Okay. So I'll get you. All right. So now the reason 3D visualization is important is because 50% of the brain's neurons are involved in vision. What it means is that what you are seeing is really what you are thinking, and that is why you have to be careful how you dress. Are you okay? Because they will be dressed, you will address the way you dress. Because when people look at you immediately, they don't care your qualification. Are you okay? They start charging because 50% of your brain is actually it's only what you are seeing. And for men, it's even worse. Women, it's even better with women. But for men, then what we see is what we cannot go for. Anyway, I don't want to go into certain areas. All right, so now it's very important to recognize that we can't make certain presentations, okay, or representations using 2 dimensions. We will have to use what? 3 dimensions. Now, what it means is that we can actually simulate spatial. So simulation means that we can, kind of fake it. Are you okay? We can try to mimic spatial reality. Okay, so I don't know if you heard about or you know about this technology where you wear glass and as if you are walking in a real, what is that called? Remind me again. This word is part of it, where you wear spectacles and then you're able to, as if you are walking in you're in a different world. Or I should give it to you as an assignment. That this word is part of it. This word, virtual reality. What? Virtual reality.
Yeah,
that's what it's called.
Virtual
reality. Cyril, it's called virtual reality. Okay. So Cyril will get 5 marks in exam for contributing. All right. So now we need to recognize that sometimes, we can only do virtual reality because we can represent in 3D, 3 dimension. We can simulate 3D. You okay? All right, but then we are only fooling ourselves when we do those things. When you think that you are looking at something and it's not there, it's actually a perception. Are you okay? The computer simply makes use of psychological cues, as if it's creating some fog, as if it's blocking. Then you begin to think, oh, maybe it's solid, maybe it's not. Are you with me? And now on YouTube, what people are doing is that they will just consider particular aircraft plane crash. Okay, maybe Malaysian airline that crashed, and they'll go and make a 3D of the airplane taking. In fact, I have tried 2 times to resist it, but you can't resist it. 3D is powerful. I watched the whole video to the end, and I'm like, someone has earned himself some money. Are you okay? Why? Because it's 3D. Okay. So the 3D is very good. So what they do is that they simply make changes in color, texture, depth, addition of some atmospheric attenuation. Are you okay? And then you begin to feel, this is real. Wow, this is wow. Are you okay? I'm not even talking about stereoscopic viewing. No, I'm not talking about that. I'm talking about just 3D visualization. Okay. All right. I think in AutoCAD it's easy to do that, but basically in ArcGIS you have ArcScene. In QGIS they have NDViz or so. There's a plugin for 3D viewing. Okay. I think I want to finish the theory first. We can do some practical as AB has requested as the SRC vice president. He wants us to do this, and we have to do it. Are you okay? All right. So 2D, we can do different layers, identify relationship between mythology, blah blah. But 3D, we can drip. Are you okay? We can cover, a terrain, an undulating surface. We can cover it with, say, NDC MPP. Can you imagine that? If you can have a 3D model of Accra dripped with MPP and NDC. Are you okay? That would be like interesting, isn't it? Okay. All right. Or because we are the election year, next week we are voting, please, guys. It's your civic responsibility to go and vote. Okay? Those of you that are voting,
vote wisely.
Right. Vote wisely. You know what to do, right? Yeah. Okay, great. So, guys, this is all I want to say about 3D visualization. There's not much to talk about, and that's it's very key and important. Okay. All right. So, any question on 3D visualization? I think in cartography we talked about relief representation, right? In cartography we talked about relief representation.
Right. Yes, sir.
How do you compare it with 3D visualization? What I just talked about. How do you compare the relief representation we talked about in cartography